Let's go ahead and take a look at a quick review of the main ideas of Module 3. So in Module 3, we begin to look at what's called measures of center, measures of spread, and what does that mean? So we start off our first lesson, and these are the guided note sheets, completed guided note sheets that I'll post. We talk first around measures of center. So a measure is an idea in statistics where we want to use a value to represent some variable in some way. And the center means on average is a way to think about it, but we have other ways now, median and mode. So that's what you see here. Now you see the hand calculations here, how to do it with hand, but we're going to be using StatCrunch, and you'll be able to use StatCrunch, and I'll show you a short example again of that. But there is a difference. The key idea here, we have two measures of center, right? Even though there's one, right? We have three, mean, median, and mode. But one of those values comes from the population and one comes from the sample. Again, here, I'm going to repeat myself now. The population mean and sample mean are different. Remember, the sample mean comes from a smaller group of the population, and we're hoping that the sample represents the population, that the sample is a good estimate for the population. That's an important idea here. And that's why we have the two different symbols. I need to know, am I talking about the population mean, or am I talking about the sample mean? X bar or mu is how we say that. That's the Greek letter M. And so make sure, again, if you need more, you go through my lecture videos. I'm doing a quick review of the main ideas. And the median, again, is important because of this resistance idea, something you want to take a look at, the resistance. Now, the median is used when the data is not symmetric, when it's not normally distributed, when we don't have that unimodal distribution, then we use the median as a measure of center, kind of figure out where is the middle, where's the average is the idea. A mode is another one. Important here is that a mode can be used with qualitative data. It doesn't always need to be quantitative. The others need to be quantitative. And then you see some examples of this here. Now take a look at, where are we here? I just want to show you quickly on StatCrunch using this data set here, where we would find some values here for measures of center as you do it. So in StatCrunch, so I have the data in 54, that data set. And what you would do is you go to stat summary stats and then columns. You have the data in columns. And so I have everything in variable one. And then the statistics we want will be here on the bottom here. I mean, all the different statistics that you may want. There's a subset already chosen for you that we'll learn more about. You compute, and there you go. That's it. That's easy. That easy. We're not going to do it. We don't have to do it by hand. And you see the different values here that we'll end up talking about. We've already talked about percentiles here. You have Q1, Q3, and other values. We'll talk about the median and so forth, mean. So keep that in mind as we have that, as we again look at summary statistics. You can actually also put in percentiles. And remember, a percentile is not a percent, it's a value inside the data set. But you could do that. So let's go back to the completed notes. So those are measures of center. We then move on to what's called measures of spread, how spread out data is. So for example, on the video you had seen, you have these values here. These are two different data sets. These are ages of people that you would encounter at these different places, the family reunion or high school event. You can see they would have different means, right? This is just a sample of people from that group. You can see the means are different, but in general, not only the means are different, how spread out they are is different. Notice how close for the band they're here. So that's the measure of spread. It's measuring how spread out the data is. It's a very important characteristic of data. And so that's what we really care about is when we think about behaviors of distributions, we're looking at centers and spreads. So in this picture, you can see a distinct difference between those two. Now to measure spread, we have range. That's an important idea, but simple. You've seen that before. It's just the difference between the max and min value. That's it, subtracting the difference. The one that's complex for many students is the standard deviation, and that's the one we use often in statistics, the standard deviation and what's called variance. Now, it's a very complex formula. It looks complex, really isn't, but you have all these terms and notations and variable labels we have for that. And in the end, the standard deviation is really just on average measuring how far the data values are from average. So think about, we have an average value, and then you think about all these data values. How far are they from the average? How spread out are they? And so here it's a small standard deviation because they're really close to the average. Here is a larger standard deviation because the values are farther away from the average. And that's what standard deviation is measuring. And you have two values. You have the standard deviation from the population and the sample. Many times we're only dealing with sample. We're hoping that the sample value is a good estimate for the population. We only know the population when we have all of the values. And so you can see the formulas that look very similar. The sample standard deviation is what we call, it's what we use for samples. And then the population for StatCrunch, we call it the unadjusted standard deviation. It's a measure of spread, and we have the symbols unadjusted. Notice, because we're not dividing it by the sample size. Here we're dividing it by the sample size. For the sample, we adjusted our estimate a little bit by dividing by n-1. My video goes through a little hand calculation. We will not test you on hand calculations. The hand calculations are a way of understanding what we're actually calculating, because that's so important as you see those different hand calculations. And then the same thing you will see once you have the data in. So here's an example here, 2, 5, 9, 11, 25. You can see here, I have that data in here in variable 3, stat summary statistics column, var 3. And then you have all of this where you see the variance, standard deviation. We'll learn about standard error. Now, if you want the unadjusted standard deviation, you have to click that there. And so that becomes part of the summary statistics, and you see you get 7 points. The unadjusted is the population standard deviation, and then the standard deviation here. And so you can see, again, that matches up to those values there that you would, we don't do it by hand, we just do it as an example here. We end this section on looking at being able to tell standard deviation by just looking at it. It's always not easy, but remember, it has to do with how far away values are from the mean, and the mean's in the middle here. This one has more values closer to the mean, and so that's why that would be the smallest one. This has more values far away from the mean. And then where do we go next? We end this section on another big idea, our z-scores, measuring how far a value is from average. And that's what a z-score is measuring. How far on average, as you can see, how many standard deviations away are you from average? Okay, you calculate the mean, you calculate the average, and then whatever your score is, you calculate how far away you are. The other giant idea for this section is about knowing if something's unusual or not. Very big idea in this class. If we observe, are we observing something unusual? So there's a way to do that through your z-scores here, that you want to know if something is unusual. You have to calculate z-scores. StatCrunch doesn't do that for us. You want to make sure you you have a sense of what that means. And then we end, this last slide is back to, I would review this around, we have all these measures now. Which measures do we use? How do I know which ones? These are the rules we use. When the data's skewed, we use, you can see here, medians and interquartile ranges, which is one of the summary statistics. If it's symmetric unimodal, we use the mean and standard deviation as our measures of center. There's my review.